One. This is lesson 7-6 from Algebra 1. And technically the name of the lesson is nth roots, which is a little bit misleading. First of all, that's just kind of a funny name. When I say nth roots, n is just kind of a placeholder for any number of roots you might want to take. So you could take a fourth root, or an eighth root, or a cube root, or even a square root. Those are all the types of math that we're tackling today. But when we talk about like cube roots or fourth roots, we usually use a notation for roots that involves a radical sign, and that's not what we're doing today. Today we're going to be doing like fifth roots and eighth roots and all of that, but we're going to be using this fraction notation for it. So really, the lesson that we're focusing on today is how to work with exponents that are fractions. What does it mean to raise something to a fractional power? So as an example here, what does 32 to the 1/5 power means? This is saying to split 32 into 5 equal factors. That is not the same thing as dividing by 5, okay? Dividing by 5 would split it into 5 equal pieces that if you added back together would give you 32. But when I say the word factors, that means multiplication, okay? Factors means to multiply. So what I'm looking for here is something times something times something times something times something that equals 32, all right? And I want to know what one of those pieces would be, okay? In other words, what to the 5th power would give me 32? So this is essentially the opposite of doing like a power. Okay, it's undoing a power of some kind. So when I ask you these questions, and I'm going to be asking you these questions a lot, there's a few different ways you could go about it, and I've kind of got a list here of some different methods. I don't know that you're going to take the time to figure out like which method am I using today. It's going to be kind of a combination of all of them. But I want you to know that the factor tree method, which we'll get to in just a second, is probably the most mathematical way of doing one of these problems. It's also the most time consuming. So I'm hoping that you'll be able to take some shortcuts using some of these things up here, and then we can also do these in our calculator as well. Speaking of that, let me get that out. So when I say memorize powers, that means can you look at this and know off the top of your head that 2 to the 5th power is 32? For some of these, you can, okay? For some of these, you know, if I gave you 4 to the 1/2 power, I hope that you would know that 2 squared makes 4. So some of these you're going to know very easily, or if you don't now, you're going to know them by the time you do today's homework assignment because you're going to do the same numbers over and over again. Some of them you won't know off the top of your head, okay? The other thing you can do is guess and check. So again, if you know it's something to the power of 5 that makes 32, and if you have a calculator available, that's obviously going to be the easiest way to go about this, is start guessing some things to the power of 5 and see which one makes 32. Okay, so maybe it's 4 to the power of 5. Nope, that comes out to be 1024, so I need something smaller, 3 to the power of 5. All right, that's 243, so maybe I'll try 2 to the power of 5. Oh, there's my winner, so that means my answer would be the 2, okay? So that's what I mean when I say guess and check, is if you know this is the question you're trying to answer, sometimes you can work around it and try to figure out what this number should be. Both of these are kind of fuzzy math, right? These are kind of reliant on some good like background knowledge, knowing your multiplication tables, all of that kind of thing. Factor trees, like I said, are your fallback method. These are the most mathematical, the most reliable way to do it. It just takes a little bit of time. So if I was going to make a factor tree for 32, I'm going to take 32 and think of some way I could multiply to make 32. So 32 I know is 2 times 16. Well, 2 is prime. I can't split that down any farther, but 16 I could multiply to make with 2 and 8. And then 8 could be 2 and 4, and then 4 is 2 and 2. So if I look at the end of my factor tree, I just came up with 1, 2, 3, 4, 5 2s, and I know that I wanted to split it into 5 pieces because this was 32 to the power of 1/5. So one of those numbers would be my answer, okay? So this is how you can do it using a factor tree. Again, I'm hoping that you don't have to do this for every single number, because once you've worked with some of these numbers enough, you'll know them off the top of your head. And then last but not least, you can do these on the calculator, but there's a reason I saved that for last, and I'll show you in just a minute. So if I wanted to just type in 32 to the power of 1/5, I could do 32 to the power, so you can see my buttons here, to the power of, now on this calculator, because it gave me the cursor up in the corner there, I can just type in 1 divided by 5, and that should give me my answer of 2. On some of the calculators, let me see if I can open one here. Some of the calculators, you're going to have to use parentheses around that 1/5. Let me show you what I mean here. So like on this calculator, I would have to go 32 to the power of, and then if your cursor just stays right there, you would need parentheses around the 1/5, okay, to find your answer of 2. Sorry, that screen's not real great, but it proved my point. Okay, so the reason I saved this calculator piece for last is you are going to have to know how to do these without a calculator. And all 3 of these methods are really going to work well for you without a calculator. Okay. Sometimes the factor trees are kind of tricky without a calculator, but usually if you can divide by 2s and 3s, you should be okay. Guess and check is sometimes a little harder without a calculator, but I'm really hoping that you are able to memorize quite a few of these. Okay, not all of them. You know, and the ones that you can't memorize, you can always do this method for. So let's talk about what happens in some weird situations with these factor trees. So we're just going to practice factor trees here. Actually, why don't you take a second and pause the video and see if you can make factor trees for each of these 3 numbers. Break them down as far as they can go. Okay. So I made factor trees for these 3 numbers, and I do want to point out your factor trees might not look just like mine, and that's okay. Really what you should do is check the bottoms of your factor trees. So for 216, I came out with a 2, a 2, and a 2, and then a 3, a 3, and a 3. Okay, so even if your factor tree broke down differently than mine, you should have those same numbers on the bottom. So the problem is we were trying to split this into 3 nice pieces. And up here with the 32 example we did, this broke exactly into 5 pieces like we wanted. But this one didn't. So what we have to do here is we have to think about this as we want something times something times something. And I do this when I do these problems. I make 3 boxes like that. And then I figure out how could I put these numbers nicely into those 3 boxes so that all the boxes are the same. So I have 1, 2, 3 2s. That means every box gets a 2. And I have 1, 2, 3 3s, so every box gets a 3. And this is all multiplication. And so that means what I just figured out is this is really 6 times 6 times 6. And so my answer for 216 to the 1/3 power is 6. Okay? And you can check that. Remember, that means that 6 to the 3rd power, 6 to the 3rd power should be equal to 216, and it is. Okay? So what about something like this next one, where I have 256 to the 1/4? So I'm going to make 4 boxes this time. And for this one, no matter how you broke it down, you should have ended up with 1, 2, 3, 4, 5, 6, 7, 8 2s at the bottoms of your branches. So notice I'm not including like this 8 or this 4 because those were broken down further. I'm only looking at the numbers at the tail ends of the branches. So if I have 8 2s and I need to put them in 4 boxes, that means every box is going to get 2 2s. There's my 8 2s, and that means I really have 4 times 4 times 4 times 4. If I really wanted to check in my calculator, I would do 4 to the 4th power and make sure it's 256, but my answer should just be 4. Okay, but what happens if it doesn't even split into the boxes nicely? So for 300 to the 1/3, I need 3 boxes. And I have a 3, a 2, a 5, a 2, and a 5. There is no nice way to put those in these boxes so that all the boxes are the same. Okay, I have 2 2s, I have 2 5s, and a 3. There's no way all 3 of those boxes are going to work. That means that this is not like a nice happy whole number. Okay, it means that it's going to be some decimal. It's going to be irrational, just like when we take a square root of a number that's not a perfect square. So if you look, if I go 300 to the power of 1/3, it's going to give me some crazy irrational decimal. I can't find that number by hand. Right? There's not a way to find it through the use of the factor trees. So just to kind of recap what we just talked about, remember this question is saying what to the power of 3 equals 300. And the fact that this wouldn't break down into those boxes nicely tells me that this number must be an irrational decimal. And I would not ask you to do one of those by hand. Okay, you have to use a calculator for that. Okay, a couple more things here. Moving on. Just a quick note on parentheses. Remember that something like this actually means to do the 9 to the 1/2 first and then make the answer negative. Okay, so 9 to the 1/2, that's really like a square root because it's splitting 9 into like 2 equal factors, which would be 3 and 3. So this answer would be -3. Okay. But this is saying to take -9 and split it into 2 equal factors. And this is essentially the same thing as doing a square root of a negative, which we know we can't do because we're not living in imaginary land right now. So this one would be no solution right now. Okay? Those parentheses are very important. When it's negative on the inside and you're applying the power, it means you're actually applying it to the negative number. If the negative's on the outside, then you apply it to the positive number and then just tack the negative on at the end. Okay, so let's try a few of these. And I'm saying evaluate by hand. When I say by hand, it's okay if you just know them off the top of your head, too. So 8 to the 1/3, the question I want you asking yourself is, do you know what to the power of 3 makes 8? Okay, and if you do, great. Correct answer should be 2. If you needed to make a factor tree for 8 off to the side, you certainly could. 256 to the 1/4. I'm going to cheat a little bit here for the sake of making your video a little shorter. We just did that one back here. 256 to the 1/4 power. Correct answer here is 4. Okay. We could make a factor tree if we really wanted to, because I'm betting you don't know 4 to the 4th power off the top of your head, and that's okay. So 1 to the 1/9 power. So just to remind you, what I'm really asking you is what to the power of 9 equals 1? What could you multiply by itself 9 times and have it come out to equal 1? Well, 1. Anything to the, or 1 to any power is always going to equal 1, okay? And so even if you have fraction exponents like this answer will always just be 1. Okay, so let's talk about this one. And this one I will go ahead and do the entire factor tree process just so you can see it. Here I've got a fraction exponent being applied to the top and the bottom of this thing. So this is really saying 125 to the 1/3 power and 27 to the 1/3 power. And I'm going to pretend I can't use a calculator here. So I'm going to go 125 and split it. And so I know that that's 5 times 25, and that's 5 times 5. And so it's split really nicely into 3 pieces for me, 1, 2, 3, and that means 125 to the 1/3 power is 5. Now I'm going to do the same thing for the 27. 27 is 9 times 3, and 9 is 3 times 3. Once again, it's split very nicely into 3 equal pieces, and so my answer here is just 3. So 5/3 would be my final answer. Okay, example 2 is solving equations using these things. And you may have some other ways to solve some of these. We'll get to that in the next couple of days here. I am going to assume that we're using a calculator here, although you certainly could do these without a calculator as well. So the whole idea here is, what power could I raise this thing to get rid of a 3? And remember that when you raise a power to a power, you multiply. So I could raise this to the power of 1/3, because when I do 3 times 1/3, that's going to cancel itself out. But that also means that I'm going to do 343 to the 1/3 power. Now, you could go off to the side and make a factor tree for 343 if you wanted to. I did promise you I would let you use a calculator here, although you will have some of these that you have to do without. Okay, so I'm going to go 343 to the power of 1 divided by 3, and I'm thinking it's 7. Yep, so correct answer here is x equals 7. And you could check that if you want. 7 to the 3rd power does give you 343. Okay, so if a 1/3 counteracts a 3, how do you counteract a 1/4? Well, with the reciprocal. So really that's what I did here is I took that 3, which is really 3 over 1, and I flipped it over. So I'm going to take 1 over 4 and flip it over and make it a 4. So then I just need to do 5 to the 4th power. You could type that into a calculator if you wanted, but it is 625. Okay. Now for this last one, just like with other solving things that we've done before, first I need to get rid of this -7 and this multiply by 3. So I'm going to start by adding a 7 to each side. And I end up with 3x to the 1/6 equals 6. Then I'm going to divide by 3. And I end up with x to the 1/6 equals 2. And then here's where the new math comes in. How do I get rid of that 1/6? What do I do to counteract that? Well, I would take this thing and I would raise it to the power of 6. And 2 to the 6th power, and again, you could check this on a calculator, but 2 to the 6th power is 64. And just like with other equations that we've solved, you could plug this back into your calculator and check it. So we could go 3 times 64 to the power of 1/6. And then I'm going to use my cursor to come back down. I just pushed the right arrow key so I can type in that -7. And I'm really hoping this comes out to equal -1. And it does, so I'm good to go. Okay, so I want you to give those a try today. I do think there's a note on some of your homework problems about which ones you should do without a calculator. I would try to rely on your calculator as little as possible so that when we get around to the end of this week and you have to do a no calculator quiz, you'll be good to go, okay? And we will talk about this. We're going to continue this lesson on Wednesday. This is kind of a big topic, so we'll keep going, okay? All right, have a great day.